Hello and welcome to another Algebra 1 video tutorial. In Lesson 10.4, we'll be solving systems by addition. Our goal will be to solve systems in which either addition or subtraction of both sides leads to an equation in one variable. Okay. The big idea, the sum of the left sides of two equations equals the sum of the right sides of those two equations. Okay. So we have the generalized addition property of equality. So if we have for all numbers or expressions a, b, c, and d, if a is equal to b, and c is equal to d, then a plus c would be equivalent to b plus d. So if we're writing this as a system, okay, so let's say we had a equals b and c equals d. What we do if we added these two equations together, the left sides should equal the total of the right side. So we'd have a plus c equals b plus d. So using this generalized addition property of equality will allow us to add the left sides and add the right sides of two equations, and what will happen is we're trying to eliminate a variable so we can solve this. Okay, I'll show you a couple examples here. So let's say we had the sum of two numbers is 5,300. Their difference is 1,200. What are the numbers? Okay, so let's set up a system first. Okay, so the sum of two numbers is 5,300. So let's say x plus y, because we have two unknown numbers. Let's call them x and y. Their sum, so we add them together, is 5,300. Their difference, the difference between the two numbers, x minus y, equals 1,200. And let's say x is the bigger number. Okay, so what we can do is we can add the left sides of these equations. So what I do is just show a summation bar and show that we're going to add. So we'd go x plus x is 2x. And we have a y and a plus and minus y would be 0y equals 6,500. Okay, now the idea is to eliminate a variable. Now look, we have an equation with just one variable. That's the idea of solving these in this manner. So now we just solve 2x equals 6,500 like we normally would. We'd take half of both sides or divide by 2, so we get x equals 3,250. Once we know x, we can find y in either equation. Probably use the top one, it might be easier. So x is 3,250, so 3,250 plus y is equal to 5,300, and then we solve that like we normally would. Subtract 3,250 from both sides, and we end up with y equals 2,050. 2,050. So there is our solution: 3,250 for x and 2,050 for y. So if we're able to graph these two, this is where they would intersect. But this is a lot faster method than graphing, because to try and find the right window here might have been a problem. Now check your answer. Does 3,250 plus 2,050 equal 5,300? Yes. And is the difference between these two 1,200? It is yes. So the sum of them is 5,300 and the difference is 1,200. So it checks out. All right. Solve this system. Negative 3x plus 2y equals negative 11, and negative 3x plus 5y equals negative 14. Now in this case, if we add these together, we're not going to get anything to cancel. So we're looking for opposites. We don't have opposites. So we either need to subtract or add the opposite of this equation. So what I do is multiply either the top or the bottom, it doesn't matter, top or bottom, by negative 1. So now the new equation, the top one won't change. Negative 3x plus 2y equals negative 11. The bottom one we have multiplied by negative 1. We've multiplied both sides by negative 1. So we end up with 3x minus 5y equals 14. Now we have a pair of opposites here, so we can add these equations and a variable should eliminate. So negative 3x plus 3x is gone. 2y plus a negative 5y would be negative 3y, and then negative 11 plus 14 is 3. So now we just solve this equation like we normally would. Divide both sides by negative 3. And we end up with y equals negative 1. Now, use any equation you want to solve for x, so maybe just use the top one, the one we started with. Negative 3x plus 2 times y, now y we just discovered was negative 1, equals negative 11. So negative 3x minus 2 equals negative 11. Add 2 to both sides. And we end up with negative 3x equals negative 9. Divide both sides by negative 3, so we get x equals 3. So our solution would be 3, negative 1. Plug those values back in and make sure they work. Okay, in this same example, notice since we added the opposite, you should remember from like chapter 1, adding the opposite is subtraction. So we could have actually, just since we have the same, we could have subtracted these two. So then you'd go negative 3x minus a negative 3x, which is 0. Then you'd go 2y minus 5y, which is negative 3y. Negative 11 minus a negative 14 ends up being a negative 11 plus 14, which is 3. And that's the same thing we got before. So you can add the opposite or subtract. Those two are equivalent math operations. All right, solve this system. 3x minus 2y equals negative 5, and 4x plus 2y equals negative 16. Decide if you need to add or subtract or add the opposite. In this case, look at these two, the minus 2y and the plus 2y. Those are opposites. We don't have to do anything but add the left sides and add the right sides, and we can use the generalized addition property of equality. 3x and 4x make 7x. The minus 2y plus 2y is gone. It's 0y. Negative 5 plus a negative 16 is negative 21. And then we just eliminated a variable, which is the whole idea, so we can solve for one of them. Divide both sides by 7. We get x equals negative 3. Now you have to pick the top or bottom one to figure out what x is, or figure out what y is, since we know x. It doesn't matter. Usually use the smaller equation if there is a smaller equation. So we'll use the top one. 3 times negative 3 minus 2y equals negative 5. So negative 9 minus 2y equals negative 5. Add 9 to both sides. So end up with negative 2y equals negative 5 plus 9 is 4. Divide both sides by negative 2. And I get y equals negative 2. So my solution is negative 3, negative 2 for my x, y order pairs. And once again, you should probably check those answers to make sure that equals negative 5 in the top one equals negative 16 in the bottom equation. And then that system will be true. Okay, one more example. Let's solve the system 2a plus b equals negative 80 and negative 3a plus b equals 120. Now, the 2a and the minus 3a are not going to cancel if we add or subtract. We have a plus b and a plus b, so this would be a case where we could change this bottom equation to its opposites, or the top one to its opposites, or we could just simply subtract. Either way will work. I showed you how to add the opposite. Let's show one with subtraction. So 2a minus a negative 3a ends up being 5a. So you can see a subtraction is a problem, or can be a problem, keeping the sign straight. So if you're more comfortable with just addition and change this to a plus 3a, a minus b, and a minus 120, that's a good bet to do too. All right, we're subtracting though. 2a minus negative 3 is 5a. b minus b is 0b, so we've eliminated that variable. Negative 80 minus 120 is negative 200. So then we solve this as we normally would. Divide both sides by 5. So we get a equals negative 40. A equals negative 40. Plug maybe that into the top equation and solve for b. So 2 times negative 40 plus b equals negative 80. So negative 80 plus b equals negative 80. Add 80 to both sides. And we end up with b equals 0. So my solution would be negative 40, comma 0. And that should be an easy check. 2 times negative 40 is negative 80, plus 0 is negative 80. Negative 3 times negative 40 is 120. 120 plus 0 is 120. So it checks out quite simply and easily there. All right, that wraps this up. Your assignment will be 10-4, page 604, 2 to 24 evens. Thanks for watching, and we'll see you next time.